Hi guys, what's up? I am Dinesh. Welcome you all to the online lecture. In this video, we are going to discuss about a very important concept, which is nothing but how to find the unit vector which is normal to a surface. To get that, you just have to find the gradient of the scalar functions. Let's your v, x, y, z is equals to 0. This is a given surface, so here we are just try to find the unit vector normal to the surface. Okay, so let vxyz is a surface given, so this gradient of v will represent the vector, gradient of v will represent the vector which is perpendicular to the surface, and to get the unit vector which is normal to the surface, you just have to find n cap, which is nothing but your grad v upon modulus of grad v. So this will represent the unit vector which is normal to a surface. Okay, so let's see an example which has already appeared in the IIT JAM examination in the year 2010, which is completely based on these concepts. Okay, so let's see the question. The question says the equation of surface of revolution is z equals to this. The unit vector, the problem is here, the unit vector normal to the surface at the point this is. So to solve or to attempt this type of problem, you just have to find the gradient of the equation of the surface. So given surface is z equals to plus minus root under 3 by 2 x square plus 3 by 2 y square. Okay, so just by squaring both side, you can write this as z square equals to 3 by 2 x square plus 3 by 2 y square. Okay, so again simplifying it, you will get 3x square plus 3y square minus 2z square equals to 0. So this equation can be written of the form this. So this is of the form a scalar function of variable x, y, z equals to 0. So as the concept says, you get the scalar function v of the function v is a function of x, y, z. So now your job to find the gradient of this scalar function, which represents the perpendicular vector to the plane, and next we will calculate the unit vector normal to this surface. Okay, so here grad of v you just can find out by using formula del v upon del x plus y cap del v upon del y plus z cap del v upon del z. Okay, so so grad v upon del x is nothing but the partial derivative of the scalar function v with respect to x. Grad v del v upon del y is the partial derivative of v with respect to y, and del v upon del z is the partial derivative of v with respect to z. Okay, so del v upon del x will give you 6x. So this will give you 6x x cap, and from this grad del v upon del u you will get 6y, so this will give you 6y y cap, and from this you will get minus 4z z cap. So gradient of the function v can be written as 6x x cap plus 6y y cap minus 4z z cap. This is x cap is nothing but your I cap, y cap is nothing but your j cap, and z cap is similar to your k cap. Okay, so this grad v, or you can say the vector which is perpendicular to the surface at a given point. So you can find the grad v at a given point a, 2 by 3 root over 0 1. You just find it by replacing the value of x, y, z in this vector. Okay, so by replacing this, you will get 6 into 2 by 3 x cap plus 6 into 0 into y cap minus 4 into 1 into z cap. So from this you will get it as, this is your twice root 6 x cap plus this will give you 0, and from this you will get minus 4 z cap. Okay, so this is the vector which is perpendicular to the surface at the point this. So to get the unit vector which is normal to the surface, you just have to find the unit vector of this grad v. Okay, so your unit vector n cap will be simply gradient of v upon the modulus of gradient of v. You have already find out gradient of v, so you just have to find the modulus of gradient of v, which is very simple, of the form this square plus this square root over. Okay, so your grad of v modulus simply can be found out by 2 root 6 whole square plus minus 4 whole square root over. From this you will get this as, I think, root under 40. So your n cap will be simply 2 root 6 x cap minus 4 z cap divided upon root 40. So by solving this, you will get this root 40 as equals to 2 root 10. So you will get this 2 here cancel. You will get this as root 6 by 10 x cap minus 2 by root 10 z cap. So replacing x cap as I cap and z cap as k cap, and by solving this you will get this divided by 2 3, this divided by 2 5. You will get 3 by 5 I cap minus 2 by root 10 k cap. So this is your required unit vector which is normal to the surface of revolution z, equals to this much. Okay, so in this way, let's see which option is correct. From this you can verify that your option B is your correct answer. So this type of problem can be solved using this way. So I hope you understand this concept better. If this video is helpful for you, then please like the video and share the video with your friends, and never forget to subscribe to the channel to encourage me to upload more and more video. Okay, so thank you so much for watching the video.